You are beautiful, isn't she? And to think, each one of those 100 billion stars has its own planets, its own strange worlds. Imagine what it would be like to visit some of those planets beyond our own little solar system. Well, today, you don't have to imagine, because I'm going to take you on a tour of 6 real exoplanets. What you're about to see is based on the latest
studying observations of debris disks and trying to find debris disks and giant planets. So the planets will form over maybe 4 or 5 million years as the star forms. So the star forms out of a massive cloud of dust and gas, and that collapses down, and the centre of that will fall and become a star. But then there'll be a whole cloud of dust and gas and stuff left, and that kind of collapses down into a disk that's just made out of kind of the leftovers from the star formation. And then that disk, the individual bits of dust will collide with each other, and they can sometimes stick together. We don't really understand yet. Sometimes they stick and sometimes they bounce off, and no one really knows how they can stick together enough to start to form a planet. But then as soon as you have a big core, we call it a planetesimal, so it's maybe 10 kilometers across. That's
I'm Professor David Vang, and I study transiting exoplanets and their atmospheres. Well, hot Jupiters are gas giant exoplanets, but they orbit much, much closer to its star than Because these planets are so close, we expect them to be tidally locked, which means the same part of the planet will always face the sun. And what that does is set up a very large day-night contrast in temperature. It's very hot on the day side, and it will be quite a bit colder on the night side. And this will in turn create
about 10 times faster than Concorde. Osiris has a temperature of around 1,000 degrees centigrade. With these temperature ranges, we're not really looking at water clouds like we have here on Earth. But at these much higher temperatures, we have the sort of evaporation and condensation cycle of things like iron and silicates. So these planets might actually have essentially, but they're likely to have a huge ocean. Now they're super Earths, they're much larger than Earth, they might have much stronger gravity, and they probably have much thicker atmospheres. That means any land features that are on these planets, any rocky features, are going to be weathered and suppressed and effectively destroyed. You can see the surface is being distorted by huge waves. There's many reasons that could cause these waves. You have an ocean which is not interrupted by land masses. So many of these planets we expect could have moons or multiple moons even, which create the same tidal effects that our own moon causes in our oceans on Earth. Additionally, actually, many of these objects might be undergoing significant tectonic activity beneath the surface of the ocean. And these waves have no land mass to crash into, so they really can build to quite substantial and what you end up with is a very soot-laden atmosphere full of particulate matter, molten rock and condensing rock and raining silicate particles, and you're going to have huge amounts of charged material flowing in the atmosphere, and that will lead us to have significant thunderstorms. So effectively, this is a pretty nasty place, probably as close to Dante's Inferno as you can imagine, with a molten lava surface, raining rock, and constant planet-wide lightning storms.
To find 7 fairly Earth-sized planets so closely spaced together around this tiny star. The star is actually about the size of Jupiter. It's really like a solar system in miniature. So here you can see the stars a lot cooler, redder and smaller, and you can see it actually looks very big in the sky here. That's not because the star is bigger, that's because the planet is a lot closer to that star than we are to the sun. So these planets can be very close in and still be kind of about the same temperature as Earth.